Hello and Assalamualaikum everyone. This is Group 1. So, my name is Muhammad Hamdi bin Khairul Anwar. Number metric is AA230 and 312. This is our presentation for our group project for fluid mechanics. So, I will introduce our group members. First of all, Muhammad Danish Uzai bin Zakaria, number metric AA230117. And the second, Muhammad Said Ramadan bin Ramli, AA233 232-035, and the next one are Muhammad Amirul Aiman bin Azmi, AA231222, and lastly is me, Muhammad Hamdi bin Khairul Anwar, AA230 and 312. Okay, next. Alright, hydraulic power units, or known as HPUs, plays a vital role into the engineering systems that require the control and transmission of large forces. HPU is a system designed to convert electrical or mechanical energy into hydraulic energy by pressurized fluid, which is then used to power the cylinders and motors. These units are commonly found in the industrial machines, construction equipment and automated systems due to their efficiency and ability to deliver consistent power. The study of HPUs hopefully provides a deeper understanding of how mechanical, electrical and fluid system integrate into a compact unit that performs complex tasks with precision and reliability. This project explores the design, function, and the underlying principles of HPUs to enhance our ability to analyze, maintain, and improve hydraulic system in practical implications.
Okay, this is an example for hydraulic power unit. Okay, component hydraulic pump power unit. First, motor. Function to convert electrical energy to mechanical energy to drive the hydraulic pump. Purpose, power the hydraulic pump to generate flow and pressure for system operation. Okay, second, hydraulic pump. Function to convert mechanical energy from the motor to hydraulic energy. Purpose, supply pressure fluid to the system to perform work such as lifting and pressing. Okay, third, gear. Function, transfer torque from motor to pump to move the system. Purpose, provide mechanical advantage and speed control between motor and pump. Okay, 4, pressure relief valve. Function, open the divert excess fluid when pressure exceed a preset limit. Purpose, protect the system from overpressure damage and ensure safety. Okay, 5, return filter. Function to remove contaminant from a fluid returning to the reservoir. Purpose, ensure clean hydraulic fluid to maintain system efficiency and protect component. Another component for hydraulic pump power unit. 6, pressure gauge. Function to measure and monitor fluid pressure in the system to convert into an electrical signal that be read by the control system. Purpose, to provide real-time pressure feedback for a safe operation and diagnosis. 7, check valve. To allow fluid to flow in one direction only. Purpose, prevent backflow that could damage pump or disturb a system performance. X, reservoir or tanks. To function, the reservoir hold the hydraulic fluid necessary for the system operation. For purpose, maintain fluid supply, enable heat dissipation and separate air audit. 9, heat exchanger. Function, cool hydraulic fluid using air or water. Purpose, maintain fluid temperature with a safe limit to avoid overheating and viscosity. Last, manifold block. Function, house or connect a valve, port and fluid passage. Purpose, reduce external piping, simplify layout and centralize control for a better efficiency.
Okay, my name is Muhammad Danish Uzai bin Zakaria. My number metric is AA230117. Okay, now my part is about the operation and how the system works. So let we discuss it, and we look at the first point is power on, which is electric motor start and drive the hydraulic pump, and the second pump move oil, which is the pump pull oil from the reservoir tank and pressure it. And oil sent to actuators, which is control valve, guide the pressure oil to the correct actuator like a cylinder or motor. After that, we can see at mechanical work done, which is the actuator use the oil pressure to move, for the example lifting, pushing or rotating. And we can see at the oil returns and get clean. After the work is done, the oil flow back to the reservoir through return lines. Before entering the tank, it passes through filter to remove dirt. And the last point is pressure control. A pressure relief valve open in the pressure is too high, sending extra oil back to the tank to keep the system safe. Okay, we go to the main component and their rules. The components, we have 7. The first one is electric motor. The function of electric motor is power the pump. And we have hydraulic pump. The function is pressure fluid. And the third is reservoir tank, which is to store hydraulic oil. And the next is pressure relief valve to prevent overpressure. Next, we have filter to clean the fluid. Next, we have control valve to direct and regulate fluid flow. And the last component, we have actuators to the main function is to perform mechanical work.
Hi, my name is Muhammad Said Ramadan bin Ramli, and I will be taking on topics 4, which is application of fluid mechanics principle in hydraulic. So what is a hydraulic power unit, HPU? The definition goes to an HPU is a complete system that uses pressurized hydraulic fluid to power mechanical movement like lifting, pressing or rotating. So what's the purpose of it? It is when a pressure is applied to a confined incompressible fluid, it is transmitted equally in all directions. So for the core principle Pascal's law, the law stated that a transformed mechanical electrical energy will transform into hydraulic energy to operate machinery. So as a result, when a force is applied at one point, it is transmitted throughout the systems, and lastly, it is efficient and it will be able to control to deliver the power delivery. 4.1 Key fluid mechanics principle in HPU operation. Pressure force relationship, which is P equals to force over area, where small force on small area is equal to large force on larger area, and it enables powerful output from minimal input. Next key principle is conservative of energy, where F1 D1 equals to F2 D2, where energy is never lost. It is just transferred, and more force is equal to less movement, and less force is equal to more movement. Lastly, fluid properties for system performance. We have incompressibility, which transmits pressure accurately, thermal stability, which works under heat, lubrication, where it reduces wear, cleanliness, prevents damage, and low volatility, which reduces evaporation. Okay, as we go on to the last slide for me, which is 4.2, components and application of HPU. The main component of an HPU is hydraulic pump, reservoir, valve, actuators, and filters and cooling system, where hydraulic pump pressurizes the fluid, reservoir stores and cools fluid, and valve control flow, direction and pressure. Actuators convert fluid power into motion, and lastly, filters and cooling system maintain clean and stable fluid condition. This application of HPU is manufacturing where injection molding, press machines, constructions. It is uses in cranes, loader, excavators. For automation, it is uses in robotics and movement system. In conclusion, HPUs are built on fluid mechanics principles to ensure power, precision, and efficiency in demanding tasks. These principles make heavy lifting and accurate control possible in many industries. Thank you, that's all from me.
Okay, this is the summary of principle. This slide summarizes the key fluid mechanics principles that are essentials in the operation of a hydraulic power unit. First is the Pascal's law. This applied to ensure pressure is evenly distributed throughout the fluid in the system. This is what allows consistent and predictable force generate in actuators. Next is the pressure-force relationship. This shows how a small area can result in a larger output force, especially when applied to a larger surface area. So next, then the principle of energy conservation. This reminds us that although we gain force, we lose some distance or speed, meaning energy is only transformed, not created. Okay, the last one, the fluid dynamics is also considered to control how fluid flows throughout the system, throughout the valves and the pipes efficiently. The last and not least, the properties of the hydraulic fluid, like cleanliness, stability, and incompressibility, determine how safe and effective the system will be. Okay, next. Alright, we have arrived at the last slide for our today presentations. So in conclusion, the hydraulic power unit is a vital component in fluid-powered systems, responsible for converting electrical or mechanical energy into hydraulic power for various applications. It functions as an integrated system comprising a motor, a pump, reservoir, valves, filters, and actuators that work together to produce motion and force efficiently. This project highlighted how fluid mechanics principles such as Pascal's law, the pressure-area relationship, and the conservation of energy are applied within the HPU to ensure consistent performance, force multiplication, and system stability. Additionally, understanding and selecting appropriate hydraulic fluid based on its incompressibility, viscosity, thermal stability, and cleanliness is crucial in maintaining operational reliability and preventing failures due to the contamination of overheating. Alright, thank you everyone for listening to the end. This is our project presentations. I hope that we get the required marks to get our project to become A's. So thank you everyone and goodbye.